Assalamu alaikum warahmatullah. This is the second video for the topic called matching techniques in microwave networks. In the last video, we learned about the L section matching. There we learned how to select which solution, which combination for the matching, and then we learned that from X, how can we choose whether it's C or L, and from B, we can choose whether it is L or C here, what is reflex. So that this is we learn, and by learning so we have some experience about how to deal with this one in the Smith chart and everything, the solution and everything. Today we move forward to another technique of matching, what we are calling the stub matching. Here in the stub matching, we will learn about the single stub matching and tuning. In the last video, when I give a little example about the single stub matching and tuning, actually stub matching and tuning, I told that there are basically two different types. One is shunt stub type and another is series stub type. Shunt basically is a kind of parallel stub type, and one is a series stub type. Both have two different criteria. One is open circuited stub, another is short. And similarly, here also, we have open circuited stub and short circuited stub. As I have described before, actually, that what is open circuited stub and short circuited stub, you can go back to the other videos, the previous video of this video, you can check that. Now, from here, I actually demonstrate this one before also in the other video, that how these two solutions can be chosen. If somebody said this is you need to design a shunt stub with either open or short, then you need to choose this one. Where this one, the feature of this one is we need to use the Y instead of Z. The Z means the impedance, so the impedance will be given, but we need to convert the impedance to admittance, and then we measure in the Smith chart the D and L pair. We already know that one approach of this shunt or series parallel stub will give us two different solution pair, D and L pair, which is this one. So this is your Z or Y. So you are here now. So you will find one is D, which means this distance, and this is L or L distance. So this is one solution, and another solution you will get D2 and L2. So these are the features actually that we need to keep in mind, that when we are dealing with shunt, whether it's open or short, shunt or parallel stub, whether it's open or short, we change it to always admittance. But for series stub, we don't need to change it to admittance, whereby we can directly plot our impedance, and from the impedance here we get D and L directly. Remember one thing which is very important, that once we locate whether it's admittance or an impedance in the Smith chart, we actually standing on the load impedance or admittance. So from load impedance, we always walk towards what? This is source, right? This is the source. Source we call actually, in terms of Smith chart language, we call it the generator here. So when we look at this one in the Smith chart, so when we start trying to find D and L, we always go towards the generator. So this one is very important to find the lengths of D and L. So in a quick summary, either it can be given, or this is actually a learning process where later on this all the knowledge that you acquire will ask you to decide which one you want to use to design a matching network. Whether it's a shunt or a series is up to you how you're going to design. But in this course, actually, it will be given that shunt, whether it's a shunt or series, whether it's open or short. So first we try to solve this way and learn how to solve this one, and then we'll deal with this one. So we move on now. Okay, this is an example directly from the Posner book, Microwave Engineering, in 5th chapter 5.2, example 5.2, where a load impedance has been given, which is RC's capacitive in nature. We can see it negative, right? And it is asking us to design single stub. Two single stub shunt tuning network means there are two different solutions. So if nothing is given, it is also inherently says that there are two different solutions. So design a single stub means actually there are two different solutions also. So again, from the beginning, we read this example. The load impedance of ZL is given, which is single stub short circuit shunt tuning network we have to design for a 50 ohm characteristic impedance line. And the frequency is given at 2 gigahertz. So this one actually have a load which it's given an additional information. But if this information is not given, then you know it actually already that this is while here, because we're going to convert it later on to admittance. So this one actually inherently it's a capacitor because this one is negative. So now before we move to our solution, we have to list down what is the basis of our solution. The basis of our solution is we're gonna do a single stub tuning, single stub matching, which have given that this is a shunt tuning. So as I told you before, here there are shunt and series, so we choose this one. So we're gonna choose this one, where D and L needed to be found. So two pairs of DLN, i.e. D1, L1 and D2, L2 we will find. And we need to keep in mind that this is a short-circuited stub. So no matter what they are asking, either it's a series or it's a shunt or it's a short or it's an open one, whether it's a 50 ohm or 100 or 2 gigahertz or 5 gigahertz, to realize this one, realize means to plot this ZL in a Smith chart, we always need to normalize this one with the characteristics impedance of the line. So it's given here, the line impedance is 50 ohm. So we're gonna normalize this one with this by dividing these values with 50 ohm, which is given here. So ZL, the small ZL, is equal to the big ZL, which is this one, divided by Z naught, as we have done it before actually. So we divide, we get 1.2 minus J, 1.6 ohm normalized. So this is our value of uh, of our interest. So this one we will plot, and then we will see how we can find the pair of D and L. D and L. Remember one thing, we all always have to go towards the generator. So here, this is I directly copied from the book. Then I will tell you actually how this whole thing happened. First of all, since we know this one already, so we will try to find out in the Smith chart. So we know that this Smith chart, this is a negative portion, and this one is a positive portion, which is inductive, and this portion is capacitive. And we know this is wavelength towards the generator, the outer one. Okay, and this one, the inner one, which is wavelength towards the load. So we will follow this one, not this one. So the number which is outer one. So first we're gonna plot which is 1.2. So 1.2 is this one, 1.2, 1.3, 1.4, and this is increasing values, right? So this is we find our 1.2 here, 1.2 here, and then we need to find our 1.6. So 1.2 we go, and then this is 1.6. So they are colliding at this point. So this is our ZL we located already. Since this is a shunt stub, I already told you that if it's a shunt stub, then we need to use the admittance value of the given load impedance. So this load impedance needed to be converted to the admittance. To do so, as we have done it before actually in the last video, that you need to draw a circle by taking radius same as this distance, and then you draw a circle, and then from here you draw a line passing through the origin until it reaches the other side of the circle. So wherever place this circle, this line touches the circle, this point is the YL, means the admittance of the corresponding ZL. So we have here the YL. So now since we are handling the value of YL, means the whole Smith chart now is admittance chart. Now since we are dealing with the admittance here, so this point, remember this point, this is a short circuit point, and this is a open circuit point. This short and open circuit point is used to determine the L values. The L values, later on I will tell you how it comes here. And to find the D, this is our point of reference. So this is the point of reference to find L, whether it's asked, let's say for this example, this is a short circuited stub, right? So we will find all L from this one. And how we're going to find, later on I will tell you. And for D, this is our basis of reference point. From here, we always try to find our D. Okay, now we are here. So we draw a line here through this one and find out until it goes out of the Smith chart. Now, this SWR circle, we call it constant SWR circle, already we have used to find YL, right? One more thing we need to add is this one. So this circle, actually, it intersect with this one circle, two different points, this point and this point. Not this point, remember this point. This point and this point. So we need to locate them, and then we need to draw a straight line going out of the Smith chart. Now, these two will give us, this is y1, right? Let's say this is y1, this is y2. So from this distance, from here, we need to measure our d. This will give us d1 and this will give us d2. Now how? Whether we're going to find it like this or like this, we come here towards the generator. We need to move. So we are here and we need to go towards the generator. This is towards generator and this is towards the load. So we move towards the generator and then we find out here this is the whole distance of the D1. So from here 0.04065 I think, and then it starts here at 0.7 something. So this point and this point, if we want to minus it, we'll find out this is D1 is equal to 0.11. So this one will give us the D2, the solution of D2. So from here we'll move and then we come here. So we find out from here the point here, then we minus it from this point. We find out the value of D2 is 0.26. By the way, this is a mistake I have done. It's supposed to be D2 and L2 here also, D2 and L2. So that's how we find already the D1 and D. This is D1 and this is D2. Now, since this is a short-circuited stub, it's given short-circuited stub. So this is for admittance. This is for admittance. This is short circuit and this is open circuit. However, for impedance, actually, this is open and this is short. In the next lecture, in the next problem, we will see that. Now it is our time to find out the L value. So to find out the L value, so we find out the D already. So to find out the L value, we need to first make some mark on the Smith chart like this, that we have Y1 here, right? So this one, the imaginary lines we follow, and then we follow here. And then we draw a straight line here. So this line is this is Y1, right? If this is Y1, then this will give you an L2 value. And this one similarly follow like this, and then we give a point here, and then we make a straight line here, and then this one will give you L1. How? Always from the short, because it's a short circuit stub. So from the short, if somebody in another problem, if say that this is open circuit stub, then you need to find out from open circuit, but always towards the generator, means the clockwise. So we are here now, and then we want to find first we're going to find towards the generator L1. So from here 0.25 we go a distance here, then it's 3 something, 3 I think 325 or something. So this distance is 0.095. Sorry, this point. Sorry, not this point. From here until the L point. I'm really sorry, not this one. This point. So we find 34 something from 25. So 0.95, 0.095, this L1. And then similarly from here, the whole circle, this is 0.25 already we have traveled, and then we add this much, will give you 0.405 lambda. So this is how we're gonna find our D1, L1, D1, D2, L1, and L2. By the way, I made a mistake here. Forgive me for my mistake. This is supposed to be D2 and this is supposed to be L2. So that's how we find it. Now, the solution is this pair and this pair. So D1 is this one, this together with this, and this together with this. So we have these two solution. So we move on after getting this one. So this one, our solution, this one, D, this value here, and this value here we put, and D2, L2 is this value and this value. And we know how to convert the ZL given to capacitor. That is your task to do. However, there is another way they can ask that if this one is the values for in terms of lambda, what is the value in terms of millimeter, centimeter, or kilometer, or meters? To do so, these are the length in terms of wavelength. But what is the physical length of these stubs, this distance of D and L? We will convert only this one now. This one is up to you to do. So at 2 gigahertz, we know the wavelength is C by F, right? So C is 3 into 10 to the power 8, and F is given 2 gigahertz, right? So if we plot this value, put this value here, we get 15 centimeter. So this 15 centimeter you multiply with this one, because this one is lambda, right? So multiplied with 0.11. So 0.11 multiplied by 15 gives us 1.65 centimeter, which is 16.5 mm. Similarly, L1 we get like this. So this is the shunt stub matching technique. So you practice by yourself. We move on to the series. By the way, I needed to change that one. I didn't change it, but it's okay. This is a next example is example 5.3, where we're gonna design a single stub series tuning. Okay, so the ZL is given, and I told you before that if this is series tuning, then we don't need to convert this one to YL. So inherently, directly we can put ZL, where we find D and the L, whether it's open or short circuit. It says the series open circuited. So this one is open circuited and at 2 gigahertz. So single stub, series tuning, open circuited stub. So we're going to find two pairs of D1, L1 and D2, L2. To do so again, the same way, 50 ohm line we have. So we divide this one ZL by 50 ohm. We got 2. Is it 2? Yes, because this is, I made a mistake. This is supposed to be 100 here. Yeah, but this one right. Okay, I forgot to change it, I think. So this is 100 should be here. And then if we divided 100 with 50, then we get 2 plus J 1.6 ohm. So this one we plot again. So if we know already that if this is a plus, this is an inductive impedance. So we go to the solution now, where the solution is, see here, it's open, right? In the previous example, we saw it is short because we were dealing with admittance. But here, we will not deal with admittance anymore. So this portion will become open and this portion will be short, which we already know that with this reference point, we will learn the distance of L1 and L2. So since we know the value of this one, the same way that we have done the shunt stub, we plot this one first. We find out our 2 here. So 2 and then negative. It's supposed to be negative, isn't it? Oh no, this one. So this 2, this is our 2 point here. Okay, this is our 2 point. And then we got this ZL here. And ZL is 1.6 here. Here, 1.6. So 1.6 and then this 2 gives us ZL. Now I already told you that we don't need to convert it anymore, anything, because it's a series stub tuning. So next thing we will do that, we will take this radius and make a constant SWR circle. This circle will intersect with 2 points of this one circle. So this one, either you denote at Z1 or Z2 or Z2 or Z1. It's up to you. Here, we have denoted this one as Z2, which will give us L1, and this is Z1, which will give us L2. In same way, this is our point, which is the D reference point. From here, we will calculate all the D because this is the Z point. Okay. So this is ZL point. So D will be measured from here and all the L will be measured from this open because it's a open circuit stub. So this open circuit, let us find the D1 first. So this is our Z1. This distance from here will give us the D1. So from this arc. So here the wavelength 0.2 something to 0.29 something here, and from 0.33 or something. So we get 0.12. Similarly, this is another mistake. D2 we find from here. Remember this one, I am going clockwise because it's always towards the generator. So from here, the whole circle I move and then I find it here. So the whole circle until this part, this. So from here, we cannot go like this. We come like this, some point here. So this is our 463. I hope that you already understand how to measure this one. From here, you measure this much, and then you add this. So we got D2 here. Similarly, from open, we got L2 here, which is 0.102, and from here we got L1, which is 0.397, and these are the two different solutions. Now, the same way we try to solve. This is our solution 1. Here we take these solutions here. This is our solution 1. This is our L, and this is our D, and this is our solution 2, which is this is our Ln. This is our. I think this is. Let me see. D. So I think I made a mistake here also. So this is supposed to be D. D is supposed to be this one, this value, this value. Sorry for that. There are slight mistakes. A little under prepared for this one, I believe. So this value will switch. So this is D is this one, and L is this. Similarly, the physical length, how you will find it, supposed to be like this. So at 2 gigahertz, we have 15 cm, and then you multiply with lambda 15 gig, you get 1.8 cm, which is 18 mm, and so on like this. Multiply this with lambda, you get 5.99955 cm, which is 59.55 mm. So this is so far all the stub tuning. Double stub tuning we will not cover in this lecture. If we need, maybe in the future we will post another video. So thank you so much for your patience. In the next video, we will learn about the matching with the quadrature wave transformer. Assalamu alaikum warahmatullah.